So now the next thing you're going to study is the units of information, the different units of information. So far I have not expressed what are the different units, right? It's not kilometers or meters or centimeters or seconds or that. It's a new type of it's a new type of units, okay? And the values of the units, right, or the name of the units actually depends on this letter over here, the base. The base represents the base of the logarithmic function, or the base also represents the number of messages, right? So if there are only two messages, 0 and 1, in that case the base will be 2. If there are 10 messages, then the base is 10. Okay, so whatever it is, depending on the value of the base, the units of information is different. Okay, so what I meant is that units of information, all right? So in units of information, we know that if b is equal to 2, if the base is 2, then I of a is equal to log of 1 by p of a to the base 2, and this unit of this is nothing but bits, bits. The name of the unit of this information is bits. Okay, bits. And if b is equal to 3, then I of a is equal to log of 1 by p of a to the base 3, and the units is triples, triples, triples. Okay, if b is equal to 4, then the information is I of a is equal to log 1 by probability of an event a to the base 4, and the units is called as quadruples, quadruples, quadruples. Okay, and if the base is equal to 10, then I of a is equal to log of 1 by p of a to the base 10, and it is called as Hartley, Hartley, Hartleys, Hartleys. It's a plural, so apostrophe s, Hartleys. Also called as Decites, Decits, Decites, Decits. Okay, and if the base is e, exponential function e, then this becomes a natural logarithm, right? So this will become I of a is equal to natural log of 1 by p of a, and the units is nats, 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 or Napiers, Neipers, Napiers. These are the different commonly used units of information. But the thing is, the most important units of information is this one, bits. We already know that, because when you're talking about an internet speed or anything, we always say it is megabits per second. Maybe you say 4 megabits per second or 5 megabits per second. That is because that is the information is all being passed in terms of 0 and 1. Basically, these are the only two symbols. In a digital age, in this digital technology, the signals are all passed in the form of digital format, right? Zeros and ones. So in that case, only two messages are there. So in that case, the units of information is always bits. So that's one thing you need to understand about the subject. Here in the subject, every information or any problems that you do, the units will always be bits, or the base must always be 2. Okay. So now I'm going to tell you what is the relationship between each and every units. The relationship between these units. Okay. That is, for example, we say that 1 kilometer is equal to 1000 meters, or 1 centimeter is equal to 100. 1 meter is equal to 100 centimeters, right? So that what are the different relationship between the units of information? Okay, so to understand that, first I assume that for the same event, okay, for the same message or for the same event, let's let I small letter a, okay, let IA is equal to log of 1 by p to the base a. Let IA is equal to log 1 by p to the base a, okay, and I small letter b be log of 1 by p to the base b, okay. So these two information are actually the same. It represents the same message and the probability of that message is p, but the only difference between these two information is that the base is different. Since the base is different, the units are also different, okay. So I'm trying to understand the relationship between these two units, okay. One unit is A array units of information and this is B array units of information. So what's the relationship between these two, okay. So this can also be written as, right, we know for a log function, right. So this can also be written as, let me see how can we write this. We know that 1 by p is equal to a raised to IA, right. It's a basic log function equation. It's another way of expressing it. And also over here also same way, 1 by p is equal to b raised to IB, right. And since both of them are equal to 1 by p, both of them are actually equal to 1 by p, so therefore I can say that a raised to IA is equal to b raised to IB, okay. So now what I'm going to do is I'm going to take log on both sides with base a, okay. I'm going to take log on both sides with base a. So taking log on both sides, okay, with respect to a or with base a. So this equation will become log a raised to IA to the base a is equal to log b raised to IB to the base a, okay. This can also be written as, since this is a power, right, the power, so logarithm of a function raised to power is that power can be used as a constant multiplication. So this will become IA into log a to the base a is equal to, and this will become IB into log b to the base a, okay. Let me write, so what is log a to the base a? Log a to the base a is 1, right. Any number which is a logarithm of its own base is actually equal to 1. So this is equal to 1. Log a to the base a is 1. So therefore I can say that IA is equal to this. I can write it like this, log b to the base a into IA, okay. Just so you can understand, that's why I just rearrange these two terms, okay. So what do you understand from this equation? From this you can understand the relationship between different units of information, right. These two are actually the same. These two are actually IB, okay, it's IB over here, okay. So these two are actually the same information, but the only difference is that the units are different. Same event, for the same message we have the same information, but the units are different. So I'm trying to understand what is the relationship between these two information, between these two units, okay. So from here I can understand that this unit is actually base is a, so therefore this unit is A array units of information, this is B array, or in other words, from here you can understand that information in A array, A dash ARY, in A array units is equal to log B to the base A information in B array units. I don't know what's the value of A and B. That's why I'm saying A array units and B array units. Okay. See, now look at this sentence. this sentence can also be, if you want to find, if you need to understand the sentence, let me write an analogy of the sentence. Okay, another way of writing. So we know, suppose, let me take meters and centimeters. Let me take meters and centimeters. So if I want to write meters and centimeters over here in this format, then this is nothing but writing like this, that is length in meters. Length in meters is actually equal to 1 by 100 length in centimeters. Length in centimeters. Information in A array units is equal to log B to the base A information in B array units. That is what this means, right? That is, this log B to the base is actually a number. It's actually a number, like 1 by 100 is actually a number. So therefore length in meters is equal to 1 by 100 length in centimeters. And so therefore from here itself I can say that what is 1 meter? We all know that 1 meter is nothing but equal to reciprocal of this, that is 100 centimeters, right? Reciprocal of this 100 centimeters. In the same way, 1 A array unit of information, 1 A array unit of information is equal to 1 by log B to the base A B array units of information. This is what it means. Okay, or if you want, so what this means is that, suppose, okay, let me just substitute a value for A and B. Suppose I'm going to put A is equal to 10 and B is equal to 2. Okay, let A is equal to 10 and B is equal to 2. So what do you find? What do you get? So information in A is equal to 10. So the name of that unit is Hartley, right? So information in Hartley's is equal to log 2 to the base 10 information in bits, right? That's what information in A array units is equal to log B to the base 10 information in B array units. That's what this means. Okay, so in that case, what is 1 Hartley? What is 1 Hartley equal to? 1 Hartley is equal to 1 by log 2 to the base 10 bits. 1 Hartley is equal to log 2 to the base 10 bits. And what is 1 by log 2 to the base 10? Let me see. Where is it? Okay, it's over here. Shift. Log 2. Okay. Raised to minus 1, right? Where is minus 1? Yeah. Okay. This is 1 by log 2 to the base 10. This is nothing but, let me see, 3.3219, or this can be written as 3.22. Therefore 1 Hartley is equal to, let me write that again, let me write the sentence again. 1 by log 2 to the base 10, 1 by log 2 to the base 10 bits, or this is also equal to 3.3219. So let me write 3.322 bits. Okay, so 1 Hartley is equal to 3.322 bits. 1 Hartley is equal to 3.322 bits. In the same way, 1 triple means base is equal to 3, right? So 1 triple is equal to, similarly, 1 triple is equal to log 2 to the base 3 bits. So what is log 2 to the base 3? Let me see. In that case, I'll take this log function, right? So let me write like this. So log 3 to the base log 2 to the base 3, okay, raised to minus 1. Our minus 1 should come outside, okay. Yeah, so this is 1 by log to the base 3, right? Log to the base 3 raised to minus 1, and this is a syntax error. Let me write that again. Yes, so log 2 to the base 3, right? Log 1 by log to the base 3. This is log to the base raised to minus 1. This is 1.5849, 1.585. So this is 1 triple is equal to 1.585 bits. 1 triple, right? 1 triple is equal to 1.585 bits. And what about 1 quadruple? 1 quadruple is equal to, let me change, for that I'll just change the value of the base over here, right? It is 1 by log 2 to the base 4 bits. Okay, 1 by log 2 to the base 4, and so I will change this to base 4. So you will get 2 bits. 2 bits, right? And what happened if I put, what is 1 nat equal to? 1 nat equal to 1 by log 2 to the base e, or natural log ln 2. You can write like that also. So log 2 to the base e bits. So in that case, let me just change this base over here to exponential function e. Exponential function is over here, right? So e. So log 2 to the base e. Okay. So what do you, how much I'll get? 1.4426, which is 1.443. So 1.443 bits. Okay. So you see, these are the different units of information, right? How I found is that by using the basic equation, that is 1 array unit of information, right? This is the equation I use, that is 1 A array units of information is equal to 1 by log b to the base a b array units of information. Okay, this is the equation I used. So therefore I get 1 Hartley is equal to 3.322 bits, 1 triple is equal to 1.585 bits, 1 quadruple is equal to 2 bits, and 1 nat or 1 Napier is equal to 1.443 bits. So you see, we want every information, the units of every information, to be in bits. Okay, even after this video, any problems that you do in the subject, you should assume that the units are all in bits, always bits. The base is always 2. Okay, because the reason is that's how the information is being transferred in this digital system, right? Always in terms of bits. That's why we put the base is equal to 2. Okay, so how to make bases equal to 2 is that you all know that since everybody is using this kind of a calculator, right? Scientific calculator, right? So here it comes with a log function over here. In this log function, I hope you can see very carefully. In this log function, you can specify the base and you can also specify the value, right? So suppose I want to find the value of log 3 to the base 2. Assume, okay, I'm trying to find the value of log 3 to the base 2. Okay, log 3 to the base 2. How do I find it? I type over here the base as 2, and then using arrow mark, I change the cursor, and then over here I choose the value 3. So this is log 3 to the base 2. Okay, and the value is 1.585. Okay, 1.585. So this is how we find the value. Okay, this is 1.585. Now, not every calculator have this system. Not every calculator might have this function, this log function where you can change the base. In that case, what you need to do is I have a very simple technique for that also. That is, suppose you have already log function in your calculator. You don't have this, you cannot change the base. You have only a single log function. Then also you can still find the base too, okay? And how is, usually in the calculator when they say just the log function, what they meant is base is 10, right? That we all know. In the calculator when they specify log 3 or when they specify log x, what they meant is that it is base is 10. So suppose if I'm going to find log 3 to the base 2 using log 10 log function in the calculator, that is nothing but just shift log 3. Okay, so this value is actually base is 10, even though it's not specified, it's understood in the calculator. Most of the calculator, every calculator will have this function, log function. And if you're not able to change the base, then what you need to do is simply find the log function of 3 normally, okay, and then whatever answer you get, you just simply divide that with log 2. Whatever answer you're getting, simply divide that with log 2 and you'll get the same value. Okay, that's very easy. So because basically we have learned that in school, that is log 3 to the base 10 divided by log 2 to the base 10 is actually log 3 to the base 2. This is an equation that you have studied in school, right? So that's what you're doing here. So even if you're not able to change the base inside your calculator, in my calculator I can change. There's a function over here. See, I can specify my base and I can also specify my number. But some of the calculators, if you're using a series lesser than this, then you won't be able to specify the base. The base is always 10. In that case, it's okay. Whatever the logarithm you're going to find, simply divide that by log 2. That's all. Simply divide by log 2. Okay, so suppose I want to find log 8 to the base 2. I know the log 8 to the base 2 is actually 3, right? Let's see if it's correct. So I'll take shift log 8. Okay, shift log 8. So this is log 8. Then what I do is divide by log 2. So you will get 3. See? So even if you want to, so don't forget that. Okay, so there are two ways of making log x to the base 2. One is by typing using the ready-made function over here, custom function. Just simply change the base value to 2 and then find the answer. The second way is by finding the log function in the ordinary manner and then divide whatever answer you're getting, divide by log 2. Okay, that's it.